I'm going to read part 2, chemical equations, and as I'm reading it, I'm going to be reading it as if I were reading it in my head and making annotations. We use chemical equations. I'm going to circle this word because this is a new word for me. To track the movement of atoms as they break their bonds and regroup and form new substances. So the atoms are breaking their bonds and they're regrouping to form new substances. And we've been talking about valence electrons. That is what is being used to break those bonds. Chemical equations are mathematical models to show the number and kind of atoms and molecules involved in the reaction. A chemical equation lists the substances that will be combined, called reactants. This is a new vocabulary word. And the newly formed substances called products. These are both bolded words. They seem important to know. The reactants are separated from the products by an arrow. Reactants appear to the left of the arrow. Let me re-say that. So the reactants are separated from the products by an arrow. The reactants are to the left of the arrow, and the products are to the right of the arrow. Since the law of conservation of matter, or mass, states that matter can't be created or destroyed, the number and kind of atoms on one side of the arrow must equal the number and kind of atoms on the other side of the arrow. That's a lot of new information. This law of conservation of matter or mass, also bolded, seems to be a definition, and it says that matter can't be created or destroyed. Okay, I'm going to move on. My directions here. I'm going to use the information listed under the material section for each of the activities that we performed in part 1 to identify the chemical formula and the substances you used in the chemical changes. Write those formulas under the column reactants in the chart below. Use a plus sign between the reactants to indicate the chemicals that were mixed together in the reaction. Okay, so I'm going to go back to part 1, and here I see activity A in disguise, and here's my materials: Ziploc bag, medicine cup, goggles, steel wool, and it's got what I'd see on the periodic table, the element symbol there, and copper sulfate. That's a chemical formula. So I'm going to go over to this part where it says the equations for chemical reactants, and I'm going to add for activity A iron plus copper sulfate. That was the blue stuff. And it combines to form, that's the arrow that I just read about, products. I'm going to get to that in a second. So if I go back and I look at activity B, I would see that I had that copper sulfate. That's the symbol, the chemical formula for copper sulfate. And I had that magnesium ribbon. For the third, I had 2 of H2O2. That was the hydrogen peroxide. And then D, that's the one where I had the ammonia and the copper sulfate. The ammonia formula, and I have a 2 in front of it, and I'll explain that later, NH4OH plus my copper sulfate. Okay, next I'm going to look at the chemical formula, and I'm going to identify the number and type of each atom in the compound. And this is what we did for homework. So the first one is done for you. H2O has 2 hydrogen, because I've got that 2 subscript, and there's no subscript for the oxygen, so I have 1 oxygen, and there's no third element. Copper sulfate, there's no subscript there, so I have 1 copper. I have 1 sulfur, and I have here I have a subscript of 4, so I have 4 oxygen. For NH4OH, I have 1 nitrogen. I have 4 hydrogen here, but then I have hydrogen again, so I have a total of 5 hydrogens. And then I have 1 oxygen. Here I have 2 hydrogens, and I have 2 oxygen. I have not forgotten about this. I want you to draw a box around here. Maybe put some stars. Put the big letter T for test. The law of conservation of matter, or mass, states that the total mass in a closed system remains the same. As a result, the number of atoms of each element in the reactants must equal the number of atoms in the products. So what I like to tell my students is, if I take a group of students from Luther Jackson on a field trip, students that I take with me, like the reactants, have to equal the students I bring back to Luther Jackson. That would be the products. Okay, so this is the law of conservation of matter or mass. So now here it says in step 4 to apply the law of conservation of matter to each equation that you wrote in step 2. Count the number of atoms of each element in the reactants and the products. Enter the information in the table and compare. Does the number of atoms of each element in the reactants equal the number of atoms of each element in the products? So here, if I look back up here, I have my iron and copper sulfate. So counting my formula, I have 1 iron, 1 copper, 1 sulfur, and 4 oxygen. Those combined, and chemically, it then turned to iron sulfate and copper. If I come back here and I count, I have my 1 iron, I have 1 copper, I have 1 sulfur, and I have 4 oxygens. So is mass conserved in this equation? Yes. How do I know that? Because the reactants equal my products. Okay, I'm going to give you what the products would be for the other 2, 3, and let's see if they match. So I had copper sulfate plus magnesium. I would now have those bonds broke and they rearranged. So I know that's a chemical reaction. So I had magnesium sulfur plus copper. This is the peroxide that I mixed with the yeast, and I have 2H2O. So I had water that was produced as one of my reactants plus oxygen. That was the gas that made the balloon blow up. Here I now have, and I've introduced a parentheses, which we will get to later on this week. But for now, copy this one down. And we're going to see if those are balanced or not. Turning to page 77. So here, what I'd like you to do is count how many magnesiums, coppers, and sulfurs, and then see if my reactants equal the products. So here I have 1 magnesium, I have 1 copper, I have 1 sulfur, and I have 4 oxygens. I'm going to put my elements in order in the same, so it's easy for me to keep track of them. So magnesium, there's no subscript, there's no coefficient. I have 1 magnesium, I have 1 copper, 1 sulfur, 4 oxygens. Is mass conserved? Yes. My reactants equal my products. Okay, let's do one more. Here I've got hydrogen and oxygen. I see that they're both capital. So that's my hydrogen, my oxygen. Here I'm going to multiply. I have 2, I have a subscript of 2 and a coefficient of 2. So 2 times 2, I have 4 hydrogen. I have 2 oxygen here, but this subscript I'm going to distribute like you do in math. So I have 4 oxygens there. Hydrogen, oxygen. Again, I distribute my 2, so I have 2 hydrogen. I distribute my 2 to this invisible 1, so I have 2 oxygens there. Once you get to the plus sign, this coefficient does not distribute, so I have 2 oxygen here. But if I add my 2 plus 2, I have 4. Is mass conserved? Yes. I'm using the word the reactants equal the products.